There's been a lot of discussion lately on YouTube as well as in the gaming press about this project, the Coleco Chameleon, which recently essentially failed and is now being cancelled. And a lot of people have spent a lot of energy talking about how they felt that the company that runs the project had let them down, it had been lying, and there's essentially a lot of kind of drama and emotion around this discussion. I find the project to be fairly interesting from an engineering point of view because it's not often that you hear about somebody wanting to set out to create a new console. So it's interesting from that point of view, and I think that's what got a lot of people excited about it when they started off a few years ago. So what I would like to do in this video is to quickly do a engineering post-mortem of the project using what public information we have. I don't have any special insights into the Coleco Chameleon or Retro VGS, which is what it used to be called. This is all just based on information that I got from reading other sources. This is something that engineers always do, is conduct a post-mortem when something fails. The reason for this is that whenever you make a mistake on a big project or even on a small project, actually, that's something where you sunk a lot of time and energy and thought into. And so you want to extract as much value from it, even though it failed, right? So what we'll do when we work on these projects that fail, and I have worked on a number of projects during my day job which have turned out to be failures or got cancelled, or we decided halfway through it was a bad idea and we wanted to stop. You always spend little time saying, okay, even though this is not going to become a product, let's see how much value we can get out of it, right? Making mistakes is very expensive. So obviously we want to avoid making them in the future. So we want to extract as many lessons as we can from every failure. So I'm going to see if I can, by picking through what people have said about the Coleco Chameleon and the Retro VGS, see if we can learn some lessons that, people who are engaging in retro gaming hardware startups can learn. The first thing to remember is that doing hardware startups of any type is actually extremely hard. They are the most risky version of startups by far, right? There's a couple of reasons for this. Firstly, funding is really hard to find because investors prefer software startups because, first of all, the overheads are very low, right? To build a groundbreaking piece of software which is super successful, you can do that with very few resources, right? Think about Instagram, for example. Instagram is like $1 billion company, and it started off being literally 3 or 4 guys in a garage writing code. And so investors love that, right? Because for a very small outlay, they can make a lot of return. Hardware, on the other hand, requires you to have a laboratory space, you need testing equipment, you need parts. During the development process, you could break some of your equipment and parts and need to replace them. So it's just physically more expensive to do a hardware startup. And so the overheads are higher, and so investors like it less. Also, it's in the hardware world, it's extremely risky to be at the cutting edge, right? Hardware is very unforgiving. In code, if you make a mistake, it's very easy to undo what you've done, go back, and then just start again. In hardware, sometimes when you make a mistake, you may have broken expensive components, or you may have used them in a way that they're not reusable in a new version. Generally speaking, it's easier to find qualified software people than it is to find qualified hardware people, just because more people are studying software than hardware today. So it is actually a fairly risky venture to be in. And so that already makes it not only unattractive for investors, but also for engineers who are getting into it, right? Because like, hey, I want to go and make something really cool. Obviously, I want it to succeed. Am I going to get into a software project or a hardware project? Hardware projects put people off right off the bat, right? And then I think the thing which makes hardware startups the hardest to do, and I've done a couple of small things. The things that makes this super hard is that consumers, the people who are going to buy your product in the end, have gotten used to essentially magic being produced out of the big hardware manufacturers, right? You think about the things that Sony, Microsoft, and Nintendo are doing with hardware. I mean, that is incredibly advanced technology, right? We're talking high definition graphics, networking, motion tracking, virtual reality, all that stuff being pushed into tiny volumes, very cheap. It's extremely difficult for anyone to match that, right? These companies have got hundreds of dedicated engineers who have PhDs in hardware. They have spent, careers, 20, 30 years working in that space. They're absolute experts. You can't expect a small number of guys getting together for a startup to match that level of experience or knowledge, right? And people have kind of gotten used to that. So when your piece of hardware doesn't deliver that, they'll immediately say, oh, hey, this thing's way more expensive than an Xbox. What's up with that? It's like, well, what's up with that is I'm not manufacturing at the volume that Microsoft is building at, right? So I obviously can't match their price. So there is a real expectation mismatch for customers between what the kind of big players are doing and what startups can do. So I said that I didn't want to get into the whole internet drama of this, and I don't, right? But I think it is worth saying that because working in hardware is this hard, it's not fair to make a pariah of the team, right? I mean, yeah, they screwed up. They said some things that they shouldn't have said, and they clearly panicked and started handling things badly. Um, I don't blame them. When you have this much energy and excitement around a project and it starts to go bad, it's a very difficult position to be in. So, my view on this is let's focus on what can we learn from this and move on to the next cool thing, right? While I've been speaking, there has been a whole parade of failed projects and prototypes on the screen showing how even big players start on projects, get a certain distance along, even get people excited about them, and then they fail. So, let's not be too harsh on these guys for essentially having their first big failure in the hardware startup world. Next time around, I hope they'll learn their lessons and do something better. So what I'm going to do for the rest of this video is we're going to break this up into two parts. We're going to see which technical lessons we can learn from the project. Technical lessons meaning stuff around, the engineering, the technology, etc. And then what management lessons we can learn, right? Managing the project, in other words, how the project was defined, the things that we're trying to achieve and so on. And then also people management. So I think the major technical problem which the Retro VGS Coleco Chameleon project suffered from was what problem were they trying to solve, or what scenario were they trying to enable for their customers, right? When these guys were talking about the machine, there was a real ethos to it. They had a strong story to tell, right? They're saying, hey, we want to go back to a time where people sat around the TV and played games together, and the games were really high quality, and all you do was stuck them in the machine and it would just work automatically without patches, etc. So they had this kind of beautiful picture of a future world, which you harkens back to this time when games were much higher quality and better than they were today. But they weren't able to kind of translate that into an engineering problem. Like, what is this machine actually going to do? That part they never actually made crisp, or they were never able to explain in detail. And I think that's one of the problems they had, because by creating this kind of fuzzy vision of the world, it allowed people to start projecting their own desires for the machine. And they were not able to come back and say, even though we paint this fuzzy picture, this is what the box will do. So during the descriptions, essentially, they talked about three kind of problems that they were trying to solve, but they were kind of very poorly defined and mixed up. And the three problems are essentially, they wanted you to play your old cartridge games in a kind of upscaled way, with on your HDMI TV with higher quality sound, etc. So that was one thing. The second thing is they wanted to bring back this idea of the kind of perfect game that didn't require patches and was bug free, etc. And then the third problem was they wanted to bring back the cartridge as a kind of physical distribution medium, because the cartridge, it's a nice tangible thing and people really loved it, etc. So problem one, which is being able to play your games upscaled, etc. That has already actually been solved, right? You can get very reasonably priced machines that will do this, right? Now I'm thinking about, for example, the Retron 5 or the Retro Freak. These are machines that have got exactly that purpose. You can stick in your old cartridges into them and they will output a high quality image to your HDMI TV and allow you to play. So it doesn't make sense to me why you would want to solve this problem, because it's already been solved. And not only that, it's extremely affordable. Like a Retron 5 goes for somewhere in the region of $150, right? How are you going to compete with them if you are coming in with a new product? You've got to start again from zero. You are competing with Hyperkin, which is used to manufacturing at scale, for example, right? So how are you going to compete in that space? So that problem doesn't make any sense to me to try and solve. Yeah, you might need to, create high quality images on your way to solving other issues, but it would not be worth creating a machine just to do that because it's already been done. So the second problem was this problem of, hey, we want to go back to a time when games were perfect and they didn't require patches and they didn't have any bugs. I don't think they understood this problem well. First of all, old games did have bugs in them, right? So the fundamental premise of what they're trying to solve is wrong. They're trying to say we're going to go back to a time which never existed. Old games did have bugs in them. It's just that because the games were simpler than they are today, you saw fewer bugs, but proportionately the number of bugs was probably the same. And also, the reason that games didn't have patches is because it was not possible to patch those systems, which meant that developers had a really rough time in those days, right? You had essentially to ensure that before you released, this thing was super tested, and you had gone through everything, because if you had a game-breaking bug, that would essentially kill your game. If you've got a small development team like an indie dev might have, this is actually just not feasible. You would never ship your game. You'd be paralyzed by the fear that your game is going to have something that breaks it. So they are trying to go back to a time which essentially no longer exists. And also, I don't know if they'd be able to bring developers on board with this, right? Because you're essentially saying to them, hey guys, guess what? I don't care that this is going to increase your development costs. I don't care that this is going to increase your time to market. All I care about is that my customers, the customers of my machine, are going to be happy with these perfect games. You have to bear the cost of that, right? That's unlikely to fly with indie developers, because indie developers have a choice. They can say, well, you know what, if I go on Steam, I can release patches and I don't have to pay that additional cost. Essentially asking devs to go back to this way of writing code is almost like saying, hey, you got to stop writing your games in C++ and go back to writing in raw assembler, which nobody would do, right? That is just insane. So that is a serious technical issue, because they don't understand the technical process of writing software. Also, if you are going to indie teams and telling them, hey, I want you to write games for my console, you have to be able to support them, right? They're going to say, okay, I'm supposed to write perfect games for this thing. How do I test them? Where's my dev console? What are the SDKs, right? What are the APIs that I call? Who do I go to for support? If I find a bug in my game, and I believe it's actually a bug in the console and not in my game, who do I call to resolve that issue? So, the big players, Microsoft, Sony, and Nintendo, have got entire teams of people who are dedicated to just supporting their developers to help them through these things. By saying, I want to enforce this bar of quality, it also imposes a big cost on your company to be able to support developers in reaching this bar of quality, right? So I don't think that they thought through this, perfect games problem. I think they thought that we'll just set a bar and developers have to cross it, but they didn't think that they would have to help people across, because otherwise developers are just going to flee to a competing platform, right, like Steam or whatever. The third problem that they were trying to solve was basically to bring back cartridge as a physical medium, right? The problem with this is similar to the issue they have with problem 2, which is doing so comes with a significant cost, right? Your game, when you sell it, is now going to have to be marked up in order to support the production cost of the plastic and the silicon that makes the cartridge. And it's not like printing a CD. Printing a CD adds cost to digital distribution, obviously, but it's quite cheap. When you're talking about putting chips down, that adds a significant cost, right? If you think about people who sell repros online, those things aren't cheap because you need to buy chips to put inside the machines. So the question then becomes, who is going to pay that cost? Are you going to expect the game developers to say, I'm going to release 2 editions of my game, one on cartridge for $40 and then one on digital distribution for $10? And if you do that, then why should developers want to go on cartridges at all? Why wouldn't they say, you know what, I don't want the hassle of dealing with the physical distribution. I'm going to go with digital only. Because effectively, your platform is competing with all these other distribution platforms like Steam and Xbox Indie Arcade and the PS4 and Indie Network, etc. So what is going to draw developers over to your platform? And this is really a kind of fundamental problem that runs through this whole project, which is, in order for it to succeed, they were positioning it in such a way that they would need indie developers to come aboard. Otherwise, all you have is basically another Retron 5, right? but they didn't consider the project from the point of view of developers, right? How do you look after these people? How do you give them the right documentation? How do you make it attractive for them to come to your platform? How do you support them? How do you help them deal with things like, oh, customers are now returning cartridges to me claiming they are defective? How's an indie dev meant to deal with that issue? They might not have people available to deal with that. Do they just forward the carts on to you as the owner of the platform? So the problem is that when these guys tell their beautiful story of this future kingdom where people sit down to play with their friends around their TV like they did in the 90s, that picture contains only the machine you built and your customers, right? Which are the people, the consumers buying your machine. The developers are not part of your picture. And so you make them a kind of second-class citizen. In order for me to build this beautiful universe, I'm going to just impose all these costs and taxes upon my developers. Well, developers have a choice of which platform they're going to go to, and they're simply not going to go to your platform if it's expensive for them to do so. But unless they come to your platform, you fail. So you need to focus on your developers as one of your customers, right? When you build a platform like a console, you have two sets of customers. One is the people who are actually buying the machine to play on, and the other one is the people who are writing the games for it. And the ones who are writing the games for it are almost more important than the guys who buy the console, right? Because without good games, no one's going to want to buy or play on your console. And I think that is something that is missing from how these guys were operating. And yeah, I know that they had contact with some indie developers to move games on, but one or two dev companies is not enough to build critical mass. You have to be able to say, I'm going to make it super easy for anyone to come aboard to my platform. And that requires a lot of cost and effort, which I don't think these guys had considered. Okay, so that kind of covers the big three problems that we're trying to solve. And the kind of meta point here is not that they handled each of these three problems well or badly. I don't think that they handled them particularly well. The big issue is that the three problems were kind of smushed together into a big mess. There wasn't a clear definition about which of these was the most important problem for them to solve. What was their vision about, which one of these things would be in the front of their marketing, who would want each of these problems solved, etc. It's just that it was a kind of big indistinct mess and it wasn't clearly thought through. The kind of second high-level problem, technical problem that these guys had was, it seems like they had a bunch of solutions lying around and they just decided to duct tape them all together into a product, right? So for example, the Jaguar molds, right? So presumably they spent a lot of money buying the injection molds for making Jaguar consoles, and they said that this would save them a lot of money because, and it's true, right? Creating one of these injection molds is extremely expensive. And so when you do that capital outlay, you want to make sure that you get as much value out of it as possible. And if they were able to get the molds cheap, it's like, sweet, one big expensive project is taken care of. The problem is that the molds seemed to kind of drive what they were trying to do, and it really was the only aspect of the project that they sunk a lot of energy into was, showcasing the molds, etc. I don't know that this is necessarily a serious problem, but it indicates to me a certain mindset of saying, okay, we've got this thing now, we've sunk a bunch of time and energy into it, and we're not willing to let go. That is a really bad place to be if you're an engineer, right? You should only kind of get married to ideas slowly over time when you become convinced that it's the right way to do it. If you have these molds and you decide, yeah, that's what we're going to go with, that should be based on something other than we were able to get them cheap, right? Does the thing you're trying to build fit inside this mold, right? That's the first question to ask. Does it limit the size of our board that we can put in there? Because, for example, let's say you want to put in, spaces for 5 different kinds of cartridges, NES, Super NES, Genesis, and whatever else. That case has got a physical size to it. Am I able to put in all the cartridges I want, or am I now limited to only doing 4 out of 5 simply because, some Atari engineer 25, 30 years ago decided it was going to be 4 inches long as opposed to 6 inches long? So those are things which should be made as deliberate, careful choices. But instead, by buying this expensive injection mold, you've now kind of locked your design to that without being able to think it through. The second solution looking for a problem was, I think, the FPGA issue. These guys claim that, hey, we can do FPGAs, it'll be super cheap because we can find people who are going to do these cores for us, etc. And so that's going to make it great. Again, like, why did you decide that FPGA was the solution simply because it was available? FPGA is just a way of doing emulation, right? It's emulation in hardware. So typically you will need, less powerful hardware to do that emulation. But today, getting an ARM core, which is able to emulate basically all of your retro machines, is very, very cheap. Like, if you think about a Raspberry Pi 3, that costs $35. That can emulate pretty much anything between a Atari 2600 all the way up to a Genesis. Why didn't you use that instead of FPGA, right? What was the thought process? What was the experiments that you ran that showed, no, it's got to be FPGA, it can't be anything else? So I think these guys kind of, had ideas lying around. Yeah, we got the Jaguar shell, we got FPGAs, we know this guy, and they decided we're just going to duct tape all that into a product without actually doing the engineering process of saying, what are we trying to achieve? Here are 3 alternatives for achieving that. Let's experiment and collect data on each alternative, and then based on the data, we will make a decision about what road we're going to take, right? I think that was another fundamental problem that they had, not making database decisions, rather taking, a solution that they already had and trying to cram it into the project, which also, it set limits on what they were able to do, and so they were not able to present a kind of coherent technical story to say, this is exactly what our machine is going to do, these are exactly the problems they're going to solve, this is the solution we chose for these reasons. Okay, so let's talk about management lessons for a minute. And why do I want to talk about management? It might seem, like, hey, that's not interesting. Managers are just the guys who kind of keep things running. What's really interesting in engineering projects and what make them succeed or fail is the technology. That's actually not true. How you manage an engineering project turns out to be extremely important in the success of the final product, because the decisions you are making are things like who is going to work on the project, what are the major pieces of this that we're going to break it into, and who's going to be assigned to each piece. When something goes wrong, how are we going to make the decision about whether we're going to cut that feature or keep it and struggle through? At what point are we going to call something too difficult to choose, and so on, right? So it actually becomes extremely important when you have a complex project like a video game console to have good engineering management, people who understand the technical aspect of it and are able to overlay that on top of the kind of market realities and what you're trying to sell and make decisions based on that, right? And I think that the Retro VGS Coleco Chameleon guys made a couple of important mistakes in their management of the project. And so, let's talk about some of those. So the first problem is, who are they building this for? The reason you need to know who you're building for is because that will enable you to connect with those people and understand what they need or what they want, right? So this is something that, for example, Apple has been traditionally very good at. Apple really understands its customer base, and because of that, they're able to predict what will be successful with those people, right? I don't think that the Retro VGS Coleco Chameleon team really understood that. At first, when they announced the Retro VGS kind of iteration of the project, it seemed like who they were targeting were kind of high-end collectors, because the machine was going to be quite expensive and it was focused on recreating the kind of experience, from back in the day. The problem with that is that, they immediately alienated a lot of people who said, well, I'm not a hardcore collector. What I want to do is just play some old video games and enjoy them, kind of nostalgia tripping. And so I don't have the money to spend on that. So their first attempt to define the kind of population of who they were building this for, they kind of settled. I don't think they made the decision consciously. I think it kind of just naturally flew out. They themselves were collectors, and so they built a machine for themselves, which is a terrible mistake to make, right? Because people like you are a very small number. So you should be identifying an audience that is large enough to give you a return on investment on what you're going to be doing. And I don't think the team really sat down and consciously made a decision about, this is the people we are building for, so let's go ahead and do that. And because of that, it kind of drifted naturally towards themselves, and so they kind of defined a tiny audience, and they failed to connect, right? And I think the proof of that is that when they started the Indiegogo, the number of supporters was very low. Even though they raised, a reasonable amount of money. I think they got up to like $60,000 or $80,000, which is, in my mind, $60,000 or $80,000 would have been enough to prototype this machine completely. A second mistake they made in terms of understanding their target audience is they confused interest in their project with commitment to the project, right? Interest to the project was very clear because when they posted in the forums, people responded and got very excited. People were retweeting and, liking their stuff on Facebook. Media outlets were running stories about it, so they thought, great, people are super interested, that will translate into funding. Well, that's not true, because just because I retweet you doesn't mean I'm necessarily going to put down $300 or $400 for your project, right? I'm not going to commit to it. And I think the fact that the number of people who actually were willing to put down money on the Indiegogo was so small is the proof of that, right? And again, that ties back to the original problem, which is because they didn't understand who they were building for, they were not able to craft the message, the marketing, being able to reach out and connect with these people correctly to understand what is it going to take for these people to commit. What is the kind of thing I need to build for them to commit money to it? The next management problem is their messaging strategy was not well thought through. Specifically, they announced the project too soon and to the wrong audience. If you compare this, for example, how the Indiegogo was handled, they did not have any technical specs for the machine available at that time. If you compare that to another successful video game startup, such as the Ouya, for example, and I know the Ouya didn't sell a lot of units, but the fundraising effort was extremely successful, right? They met their goal and they were able to mass produce a machine. When the Ouya Kickstarter went live, they had full technical specs. And you can still go back to Kickstarter.com and read the Ouya page. They actually say, hey, we are going to have an ARM processor. It's going to have one USB port. And they had explicit description behind every single one of those choices. This is why we're doing this. This is why we believe it's enough. The Retro VGS, on the other hand, did not have anything like this. The Indiegogo was, again, they were kind of expounding this ethos about we were going to go back to this beautiful nostalgic land, but no hard specs. And here is the problem. If you take that story about, we are going to try and create this beautiful world, and you take it to, for example, professional venture capitalists, they might be able to look at that, and because they have experience in funding projects and understanding which projects succeed and which fail, they might be able to take that story and in their minds decide, yeah, this is worth funding. I'm going to give these guys money because I think what they're trying to do could probably be achievable with X thousand dollars. The general public is not able to do that, right? Because the average person in the general public does not have a lot of experience with engineering projects than the probabilities of success or failure. Essentially, when you go to a person, a random normal person, you tell them about a project like this, the information you give them, they consider it to be a promise from you about what you will deliver. So you need to be extremely careful that you have high confidence in what you are communicating at any given point when you're reaching to, just general folks. And this is why the Ouya, for example, was extremely explicit and said, this is what we are going to build. Because instead of basically putting up a page that created a lot of questions, how's it going to work? And does it do this? And will it be able to do that? The Ouya page answers questions. It is going to have these things, and therefore it can do these things. And the technical information was such that even if someone had a question, somebody else would be able to answer it for them. So the third management issue they had was essentially they had a good vision for the project, and this is the ethos that I've been talking about, but they had absolutely no technical vision for the project whatsoever, right? There was nobody on that team who was able to say the machine is going to look like this. These are the specs. This is how we will improve it in the future. This is what a version 2 will look like. This is the peripherals it's going to support. This is the amount of power it's going to draw, etc., right? There was no kind of technical architect driving the creation of that machine. It was purely driven by the kind of marketing and the kind of, nice, fluffy, warm feeling that the project gave you. When you are building hardware, you have to have someone representing the technical aspects of the project who is extremely confident in speaking about that stuff, so that when someone from the media asks you a bunch of awkward questions, you need someone who can come back and give clear, confident answers and say, well, to answer your first question, it is going to do this, this, and this. To answer your second question, we don't know yet, we're experimenting with these two alternatives, and so on, right? If you think about massively successful hardware companies, this is what they do. The person in charge who represents the image of the company is technically extremely solid, right? So for example, let's think about Nintendo. Satoru Iwata, who just passed away recently, who was the CEO, this guy was, during the 80s, he was writing games. So he understood the gaming industry and hardware from the point of the developer all the way up, working his way through all of the stages of production to being the CEO, right? So when Iwata would talk about the technical aspects, he was extremely confident because he understood every single detail. And if someone asks you a question, I think you guys are full of hot air, and you come back with really detailed, confident discussions about the technical aspects, that makes people feel good, right? That makes them feel like the project can succeed. The same thing at Microsoft, right? Phil Spencer is the head of the Xbox division. Spencer has been a developer at Microsoft since I think 1988, right? This guy has been a developer, a development manager, a vice president. He understands all the technical aspects of the Xbox inside and out. And so when someone asks him a question or tweets something silly, he can come back with solid information and put minds at ease to say, yes, you're quite right, that is a problem we're working on, or no, you're quite wrong. The issue that you're concerned about is not going to happen because of XYZ reasons. So this is something that the project was really sorely lacking. They should have had someone driving the technical aspect of it. They had one very good technical person involved with the project early on, this guy Kevtris, who was working on the FPGAs, but they treated him like a vendor. They were just going to buy the cores from him and run them. Right? He was not going to be the person who was going to front the technical aspects and say, hey, I'm the chief engineer for this project, so I'm going to tell you exactly what this thing's going to look like. And people would have trusted that because he already had quite a good reputation in the community, right? So I think that was a very serious management issue on their side. So the final management problem I think they had was they essentially didn't have the right people together, right? They did not assemble a good team to handle this project. Some of the people were the right people, right? And I think Mike Kennedy has attracted a lot of kind of ire because, you know, he's flip-flopped on some statements. When people have asked him awkward questions, he's gone radio silent. But, you know, you can say what you want. When Mike pitched the original idea, people got very excited. He was able to bring people with him to that kind of mythical world. But that alone was not enough. Who was the trustworthy person who was in charge of the technical aspects of the project? Who was the trustworthy person who was in charge of business development, of customer relations, of developer relations? What they should have done is they should have sat down and said, okay, this is the project. It's going to require us to build hardware. It's going to require us to build software. It's going to require us to reach out to developers. It's going to require us to raise funds, etc., etc., etc. And they should have found a good, solid person for each of those major roles. And then that becomes your management team, and from there you move on, right? Without having those right people in place, or without even stopping to think about what you need, what you end up with is this very kind of, you know, all hands thing where people have to pitch in and help even though they don't understand the space. And when that happens, you make serious mistakes, right? Again, going back to the Ouya project, right on the Kickstarter page, they actually list who the key people are, and with, you know, a mini resume for each. So even if you don't know who these people are, you can say, whoa, the guy in charge of business development, man, look at that. He worked on all these successful things, which means this new project is probably going to be successful too, right? That is something that they didn't do. They didn't communicate the team well. They didn't establish the structure nicely. And I think that was a problem for them. Right, so that's my brief postmortem on the Retro VGS Coleco Chameleon project. I would be interested in getting feedback on this. Do you agree or disagree with some of the lessons we can learn? Did I miss out any major lessons? Let me know, put a comment down below, and we can start the discussion. So keep gaming and take care.